Imagine a world where our moon holds the key to humanity's future energy needs and beyond. The discovery of a rare crystal on the moon by China's Chang'e 5 mission challenges everything we thought we knew about our celestial neighbor. What if this finding could transform the way we approach energy consumption on Earth? Stick around as we delve into the implications of this groundbreaking discovery and what it means for the future of space exploration and energy generation. What if our understanding of the moon is just scratching the surface? Could a single unexpected discovery upend everything we thought we knew? For years, researchers believed they had unraveled the mysteries of the moon, until a surprising substance shook China and the scientific community in 2019. Is this the dawn of a new era in lunar exploration? And why is China suddenly leading the charge in this celestial competition? The revelation came unexpectedly, with physicist Michio Kaku inadvertently disclosing a groundbreaking find during an interview. The discovery, made by a Chinese lunar probe, remained shrouded in secrecy until then. Following its inadvertent disclosure, the China National Space Administration confirmed the existence of a lunar resource with transformative potential. In 2020, a rover unearthed a rare crystal buried deep within the moon's basalt particles, previously unseen and untouched. This crystal, forged during an ancient volcanic era over 1 billion years ago, hinted at revolutionary implications for Earth's energy landscape. The Chang'e 5 mission marked China's pioneering endeavor to retrieve lunar samples, unveiling a mineral dubbed Chang'e after the rover and the moon goddess Chang'e. What set this crystal apart was its hidden treasure, helium-3, an elusive element with the power to revolutionize energy generation, scarcely found on our planet. As the world marveled at the groundbreaking discovery, it became evident that the moon was poised to shed its silent demeanor in the night sky, offering Earth a pathway to a promising future. China's conquest of the moon through spaceflight emerged unexpectedly, with the nation's historical ties to rocketry tracing back to ancient innovations in the 9th century. China's space endeavors, though not part of the mid-20th century space race, commenced in the late 1950s and progressed independently following the dissolution of the Soviet Union. With the launch of its first satellite in 1970, China embarked on a journey of technological advancement, culminating in milestones like the Chang'e lunar orbiter in 2007 and the Shenzhou 7 manned spaceflight in 2008. Initially overlooked, Chinese lunar missions gained international attention with groundbreaking discoveries, highlighting China's ambition to lead in space exploration. The world was stunned when China's lunar program captured attention with the discovery of a peculiar substance on the moon's dark side by the Chang'e 2 mission. Images revealed an orange-yellowish gel-like substance, sparking intrigue about its origins on a supposedly lifeless moon. While Western scientists speculated it could be a form of glass or rock formed by celestial impacts, the lack of comprehensive information from Chinese sources left many questions unanswered. Chang'e 2's feat of navigating the challenging terrain of the dark side of the moon underscored the technical prowess of the Chinese National Space Administration, prompting admiration for its achievements in subsequent missions. The future of power generation appears poised for transformation as the moon's newfound potential hints at untold riches. While NASA and ESA previously showed little interest in lunar exploration, SpaceX Elon Musk's vision for economic lunar development prompted a revaluation of lunar projects. Now, with the discovery of a rare lunar crystal containing helium-3, the landscape of global energy production stands on the brink of revolution. Helium-3, a light, non-radioactive isotope suitable for nuclear fusion reactors, holds promise for clean and efficient energy generation. Unlike conventional nuclear fission, which produces radioactive waste, helium-3 fusion offers minimal byproducts, envisioning a world with abundant, cheap, and sustainable energy. Amidst the urgency of climate change, this discovery could serve as a pivotal turning point, offering a solution to our environmental challenges. Recognizing the strategic significance of helium-3 and lunar resources, China, already a global superpower, stands poised to lead in their exploration and extraction. However, technological challenges remain, including the cost-effectiveness of transporting helium-3 to Earth and establishing lunar supply chains and mining operations. The advent of helium-3 as a fuel for space travel could also herald a new era of exploration. With fusion propulsion systems offering efficient and sustainable energy, spacecraft could embark on longer missions with larger payloads, potentially unlocking expeditions to distant planets and star systems. In essence, the discovery of helium-3 on the Moon not only promises a revolution in energy production, but also offers tantalizing prospects for space exploration and the future of humanity's journey beyond our planet. Lunar regolith, the rock and dust covering the Moon's surface, long dismissed as uninteresting, now emerges as a valuable asset for establishing a permanent human presence on the Moon. This crucial resource holds the potential to support future lunar settlements by extracting water and oxygen through chemical processes. Techniques developed by the European Space Agency, ESA, can extract oxygen and metals from regolith, offering a lifeline for sustaining life and powering rocket propulsion systems. Producing oxygen directly on the Moon would reduce reliance on Earth's resources and enhance the sustainability of lunar bases. Plans are underway to establish an oxygen pipeline from the North Pole to NASA's Artemis lunar settlement, ensuring a vital supply for future lunar settlers. Additionally, regolith serves practical purposes as a building material, capable of constructing protective walls and habitats using innovative 3D printing technology. The achievements of the Chang'e 5 mission continue to unveil surprises as Chinese scientists uncover water enclosed in tiny glass beads within lunar rock samples. These abundant glass beads, formed during ancient volcanic activity, contain traces of water that, when combined, could fill an ocean. This discovery enhances our understanding of the Moon's geological history and offers a reliable water source for future lunar settlements and industrial facilities. While water ice exists in shadowed craters at the Moon's poles, extracting water from glass beads may prove more accessible. Furthermore, these icy craters could potentially provide up to 600 billion kilometers of water, surpassing the volume of Lake Superior. The once arid and inhospitable Moon now emerges as a potential savior for our planet. The discovery of helium-3 within lunar crystals by China's Chang'e 5 mission marks a significant milestone in both energy generation and space exploration. This revelation not only redefines our understanding of the Moon's potential, but also positions China at the forefront of a new space race. As we stand on the brink of revolutionizing energy production with clean, efficient fusion power, the implications for environmental sustainability and future lunar colonization are profound. The Moon, once thought barren and desolate, now emerges as a beacon of hope, promising a brighter, more sustainable future for humanity. Stay tuned as we continue to explore the limitless possibilities this discovery unveils. How do you think the discovery of helium-3 and other lunar resources will shape the future of energy, space exploration, and our relationship with the Moon? Feel free to express your thoughts and viewpoints. And be sure to join the Revel Discovery community by hitting that subscribe button to stay up to date with lunar revelations and the forthcoming frontier of space exploration. Remember, as we venture into the universe, the sky is not the limit, it's just the beginning. Keep looking up.